Looking at problem 5 from the worksheet for 6.5. So we're told that a stone is thrown into a pond. The ripples travel outward in this fashion so that the radius of the circles increases at a rate of 3 feet per minute. We're asked to figure out the rate at which the area is changing when the radius is 11 feet. So basically, the point that the stone hits the water, you've got ripples sort of going outward from the point of impact. We're looking at sort of one of these. It has a particular radius, and then there's an area associated as well. And you can see that as the radius increases at this rate, the area is going to increase at kind of a lot faster rate, because you can imagine that if looking even just at this drawing here, if the radius has doubled, maybe kind of similar to what I have drawn here, the area is clearly more than doubled, so the rate at which the area is changing is going to be much faster than the rate at which the radius is changing. Anyway, we're told that the radius is increasing at this rate. When we see the word increasing or changing or anything like that, we know we're dealing with a derivative. So the rate at which the radius changes is dr dt, and then we're interested in the rate at which the area is changing. That's dA dt. Finally, we need the relationship between the two quantities. That's pretty hopefully well known. The area of a circle is pi times the radius of the circle squared. And so then we take the derivative of both sides of this with respect to time. Derivative of a with respect to time is dA dt. This one we use the power rule, put the 2 in front to get 2 pi. Lower the power by 1 to the first power, and then we also have to multiply by the derivative of r with respect to time. That's dr dt. So what we want is dA dt when r is 11, and so we just plug that in to our formula here. So 2 pi, radius is 11, and we're told that dr dt was 3, so multiply all this out. 11 times 2, 33, times 2, 66. So 66 pi feet squared per minute. The units on this because it's area. So if we want to approximate that, 66 pi will be 207, roughly 207.3, so about 207.3 square feet per minute. Okay, so again, what this is telling us is that at the moment when r is 11 feet, the area is changing at a rate of 207 square feet every minute. So it's going to be getting bigger at that rate. But again, only at this moment in time. This value will actually get larger if r was larger again. So at this moment in time, the area is changing at this rate.